Hey guys, it's Milo. Here with another Matlab tutorial. This one's going to help you with your wind turbine project. I'm going to show you how to modify one of the existing scripts that you were given for the project to help you with the design and analysis of the wind turbine. We're basically going to be adding a for loop to help us iterate over um, a bunch of different parameters systematically, and then I'll show you how to plot it all up. This is going to help you look at a bunch of different number of blades or a bunch of different tip speed ratios at once. Or let's say you found the perfect number of blades, then you can vary the tip speed ratio or vary the wind velocity to find a good configuration for your wind turbine. Alright, so basically we're going to be putting a for loop. This is the get blade design script, and we're going to be putting a for loop around the majority of this script. So we can start even up here and just write for and end, and we're most of the way there already. We can take out some of the stuff we don't need. We don't need to plot blade angle and blade chord for every iteration. Essentially what we're doing right now, and actually here's another quick little tip, you can press dot 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 and then enter, and MATLAB will interpret everything after the 3 periods. So essentially it'll interpret this line as if it's still on this line, and it just makes stuff easier to read. Sometimes when you have a lot of outputs and a function with a lot of inputs, it gets carried off the screen. And so that's all that's going on there. I'm going to separate this. So this is really what we want to do is we want to run the BEM function a bunch of times for a number of different blade angles, wind velocities, and tip speed ratios, and plot the output of the BEM function, so efficiency, power, RPM, etc., for all the different inputs. So let's say we try 5 different number of blades. We can try 3, 4, 5, 6, and 7 blades. Then we should have 5 different answers for efficiency, power, and RPM, and so on, corresponding to the 5 different blades. And if we check 10 different tip speed ratios, then we should have 10 different efficiencies, 10 different powers, and so on. This does not need to be inside the for loop. That doesn't change. So first thing we'll do is we will check a bunch of different number of blades. We'll lock the wind velocity and the tip speed ratio at 5, both at 5. And we will check a bunch of different number of blades. So like I was just saying, if we check 5 different blade numbers, let's do 3, 4, 5, 6, 7, 8. Let's do 6 different ones. Then we should have 6 different answers for efficiency and power, and the other outputs. So if we were to run this through right now, we don't have an incrementer yet, but let's say we were to run this through for all the different number of blades that I just typed up here. Efficiency, power, RPM, torque, and stall, those variables would get rewritten every time I run through the BEM function. But we want to save all that information so we can plot it and look at it and analyze it. So we need to put those numbers in arrays. We need to put those numbers in lists so we can look at them later. So we need to we need to initialize them. And to do that, we're going to create arrays of zeros. We'll get to the size in a second. I'm just doing this to make it quick. So if we have, if we want to check 6 different blade configurations, then we are going to have 6 different answers for efficiency, like I was saying. And we need places for all those numbers. So we're going to make an array that has 1 row and 6 columns for efficiency and for all the other output variables. And now we have a place to put all those numbers. one thing that we can do to make our lives a little easier, because we may change the number of blades that we want to analyze, we may end up needing to add a seventh one. So what we can do is we can make a variable, we can call it whatever you want, call it n, and that'll be the number of cases that we're going to look at, and we can use this built-in function length in Matlab, and that will extract the length of an array. Basically what it does is, so every array is essentially two-dimensional, even if it's just one row or one column. It's this is a 7 by 1 array, and length will return the longer of those two dimensions. So in this case it would return 7. And now we can, instead of explicitly writing the number of columns, we can just write n, and if we want to add more or take away, then we don't need to go into here and change all these numbers too. So I'll suppress all these. So now we're at the for loop. The for loop is going to run once for each of these elements. So we want a counter that will go through all those elements. There's 6 of them, and we want to start at the first one and go through all of them. So we will call our counter I. It's a common name for a counter, and it will go from 1 to n. And it's going to be looping through this numBlades variable, right? So we're going to need to find all the instances of numBlades. You can do that by double-clicking on it. That'll highlight all the instances of numBlades in your whole script. If we look at inside the for loop, there's 2 instances of numBlades, and we're going to need to put the counter next to those, so that when I equals 1, it will be using the first element of numBlades, which is a 3. And when I equals 2, it'll use the second element of numBlades, which is a 4. And so on. I'll be saying that a lot. So if we have essentially 6 different inputs that we're trying for numBlades, that means we're going to have 6 different output answers for all these guys, and each of those also needs to be incremented, so that when we run through the for loop and numBlades, let's say I equals 2 and numBlades equals 4, that we want to put, so that's essentially, if I equals 2, we're talking about the second run of the for loop. So the answers that we get from that second run for efficiency and power and RPM should go into the second elements of those arrays that we created. So the first run, all those answers will go into the first slot. The second run, all those answers will go into the second slot, and so on. Alright, so this should actually be ready to go. I'm going to run this, and we'll look at the answers. Let's look at efficiency. So we have 6 different answers for efficiency corresponding to the 6 different blade configurations. If you scan across, you can see that this is actually the maximum, and then it starts to decrease. So that is the 5th element. So that corresponds to 1, 2, 3, 4, 5, 7 blades. So the 7 blade configuration for this wind speed and this tip speed ratio turns out is the most efficient. So now let's say we want to lock in the blade number at 7, and this may not necessarily be the approach you want to take to designing the most efficient wind turbine, but this is a decent approach. So we'll lock in the number of blades at 7, and we'll try a bunch of different tip speed ratios, keeping the wind velocity where it is. So we'll make this an array now, and we'll try 4, 5, 6, 7, and 8 for tip speed ratios. And now we're going to need to modify a few other things in the code. So now, since we're checking tip speed ratios, n should be length TSR instead of length numblades. And then down inside the for loop, we're going to want to, let me move this over, remove the counter from after numblades, since we're not varying numblades anymore. And we're going to put the counter on TSR every time we see TSR, so we can double click it and highlight all of them. So there's one right there. And just like before, counter is going from 1 to n. N is the length of TSR, which is 5, right? 1, 2, 3, 4, 5. The first time the for loop runs, it's going to start at 1. Every time TSR is called, it should appear as TSRI, which will grab the ith element of TSR. So if it starts at 1, I is 1, and TSR1 is 4, because that's the first element of TSR. And it'll run through, and it'll give us answers for efficiency, power, RPM, torque, and stall. And all of those answers will go into the first slots of these arrays that we initialized before. So when I is 1, efficiency 1 will go into the first slot of the efficiency array. And when I is 2, efficiency 2, will, parentheses 2, will go into the second slot of the efficiency array. Alright, so let's run this and see what happens to the efficiency. So it looks like there's a maximum inefficiency around the second entry, so around 5, which I think is what we were at before. So it seems like that might be a good tip speed ratio for this configuration. So now TSR and numblades, neither of those are arrays, and if you run it like this, it basically since TSR is just 5 now, length TSR returns 1, so n is 1, and essentially the for loop just runs once, and it basically kind of degenerates back into the original script. And you see it just gives you one answer for efficiency and power, RPM, torque, stall. Okay, so I have another version. So this one is still modifying numblades and not TSR. I think you guys can figure out how to modify vwind if you had to. Not that you necessarily have a choice of that in your design, but you can change it, and you can look at different vwinds, look at the performance for different vwinds. So I have some plotting stuff down here. So this one is varying numblades, and I'm plotting efficiency, power, RPM, torque, and stall versus numblades. Again, this might be something that like you might want to change TSR instead of numblades, so I created this variable indvar, meaning the independent variable, the variable that we're independently changing. So that's like the x-axis. And I'm plotting all the outputs versus that indvar. And here I'll show you what this looks like. I'm using a subplot, which is really useful for putting multiple plots on the screen at once. When you use subplot, this is basically the number of rows, and this is the number of columns of plots. So there's 2 rows of plots, 3 columns. And then the third number is where that particular plot goes. So they're actually numbered in the following fashion. Hold on. So like 1, 2, 3, 4, 5. So they all have this subplot 2, 3 because they all go on the same 2 by 3 window of plots. and you put that before a normal plot command, and it will put that plot on a subplot. So this plot is really useful for looking at the numbers uh, that we were just looking at. It's obviously much easier to see the maximums here, and if you use a lot of numbers, like, well, I guess it doesn't really make sense for number of blades, but let's leave number of blades at 5, and let's try a bunch of different tip speed ratios with lin space real quick. We make 100 elements evenly spaced between 3 and 8 to give us some nice smooth plots. And we're varying the tip speed ratio, so we need to put I after TSR. Take it away from there. And we'll change indvar to TSR now. And TSR. Well, it doesn't look as smooth as I thought it would. Yeah, let's try that again. Let's go from 5 to 8. So you can see it gets kind of hairy over here. But there's a nice trend in power and efficiency and torque. Alright, cool. I think that's everything that I wanted to talk about in this video. If you have any questions, leave them in the comments or email me. Office hours are still Monday 12 to 2 and Thursday 1 to 2. And if that doesn't work out, send me an email and let me know what your schedule's like, and maybe we can work something else out. Alright guys, thanks for watching. Good luck on the project.